Let's get started. I believe she might take some time. uh, yes. Okay. So we were looking for overall, SOC, business, how SOC is being constructed. What are the needs of SOC? These 8 points are really important, basically, to understand what SOC does on a larger scale. And whenever we start introducing ourselves, and when I say what you do at SOC, we have to mention these things like log collections, reporting, part of R&D, threat intelligence, knowledge-based ticketing, SIEM, and aggregation and correlation. And these are the things basically expresses SOC for an organization. What SOC does was the need of a department of an SOC as an independent entity, right? So for that matter, we clearly try to build or secure the company or organizational infrastructure as well as products, as well as whatever entities we are basically targeting in terms of even external entities for some organizational reach. We try to handle it through these 8 elements. These are the basic crux of the SOC. Then we see how the overall SOC handles this thing in terms of process arrangement. Then we see around the hierarchy of SOCs, right? How SOC is structured centrally, globally. Then we have regional reach. We have a city, a village, or state level reach, or county level reach, and then a facility level reach. So we might have a separate, head of the SOC for a particular physical building or a logical unit also. And this way we normally try to reach each nook and corner where we can see there's a threat, there's a penetration could happen as far as overall security concerns are concerned. And we are not just looking at cyber security here, all there are physical security. So most of the organizations thinks that even the physical security is a part of cyber security, and I think that's a kind of general industry standard nowadays. Okay, there could be some question in terms of why and what not. I'll not have these thing and that thing. These things do happen, but I believe those are kind of exceptional scenarios. So we try to treat even the physical security, the security guards and all those things also a part of cyber security. Now, what are the skill sets we need? We had a look at these things last time. Okay, so what we need to have, normally the way the JD is spanned off, the JD is shared with us, is basically you need to work independently, because as an analyst, as an overall an intelligent agent, you should be able to analyze overall how the security threat can be penetrated for a given scenario. So it can be for a particular domain, a particular industry on a whole, or a particular location as well. Like we discussed, a specific building or specific office we are targeting as far as assessing security and building it a better day by day. And we do evolve. So this is not a ribbon cutting ceremony. You continuously do vigilance. You continuously try to detect certain anomaly, certain out of the box or what you can say out of the ordinary things, and we try to check out if that can be a threat to our security. Like we've seen at airports, there are normally announcements like if you see anything which are lying, just lying there, and you shouldn't touch it. Basically, you should call the cops, or you should call the agency which basically analyze the thing and then hand it over to certain agent or certain office which can basically share that thing after the ownership has been proven, and so on and so forth. That's how we do it, because rather than touching anybody else entity bag or something like that, it's better to first analyze it, first go through it for any harmful nature or any such criticality in terms of damaging scenario to be contained. And that's how we do these things. Then communicate the severity of the threat and recommendations or remediation and all those things to the with the relevant authorities, I'll say, because this is what the analyst needs to do. As a typical analyst, right, we do analyze things on a ground. So whenever you're walking into office, you are basically analyzing the scenario, analyzing the environment, analyzing the surroundings, and try to understand where the security can be leaked out, where the security can be damaged or handed loosely, and then we try to tighten those things up. So we are concerned about the security in terms of the tangible, intangible product, as well as the physical security, right? Actually, well, that intangible thing covers the physical security, but yeah, that's how the industry feels. So there's a extra stress on that physical security quite a few times. And follow the detailed processes. See, every organization has their past, right? The way they have tackled these threats in past, the way the cybersecurity department have taken good initiative in that organizations basically tells us how those security matters are being handled currently there. So how they handle, they might have formed some policies and procedures to attack security. Like everybody should have an access card. We normally have those plastic cards, right? Like credit card. You have to touch them on those scanner at the entry point, and then the doors let you, because doors basically note down your attendance and all sort of other things also nowadays. So this is how we basically trying to address security also. So there are quite a few other policies and procedures get channeled to these security matters. Like I said, that access card, right? Access card is a simple thing to let the person access given to the office or a physical facility and so on and so forth. But still we use those data collection at access point as a really great measures to tackle all security leakages. Is somebody, let's say Ravindra takes Santosh card and access those things, how we're going to tackle that thing, right? So we in really if you want to basically understand this scenario, there are quite a few US military offices, what do you call intelligent offices there, where even if I stole somebody else's card and swipe that card, the door will open, but then whenever that face recognition routine has completed, it starts alarming, boss, this access card has been stolen and being used by some other person. And this happens even really funny scenario, like a person which who might have grown mustache and start doing that face recognition thing, right? So there are certain points in face recognition which basically skip that mustache, and it starts giving signals like, okay, the personality is not the same, whatever you have been reported to me. So there's a mismatch, and that mismatch triggers those alarms also. So these are the scenarios, and we are learning from it. So what we do next time, we might ignore those mustache thing, or we'll have that resource report their latest picture to the security center outside the gate. We keep a security outpost or something like that, sir, where your face recognition should be approved whenever you walked in. Now this can be a leak or a threat to overall physical access security also. So we need to tackle them in that level, that scenario, and so on and so forth. So we have fingerprint center, we have iris scanners, and so on. So there are various level of such access security have been matured, because access security is one of the most prominent, or what I can say, eye-catching scenario. Wherever you go to office, this security, the physical access is being monitored and recorded most of the time 24/7. And this is industry adopted processes at quite a few places. And nowadays, whenever you walk into office, you can see a board saying, this your presence is being recorded, so please be aware, and so on and so forth. So there are these are kind of legalities involved. So there are some legislation regarding this recording of a person walking into office, and which is made now a general practice. And this is how we are doing it. So what we are doing, every person who is accessing the office physically have to have an access card. His access point is noted, his access time is noted, and his credentials are normally matched with the credentials which have in our library. And this we do as a regular practice. And there are legislation, there are some policies and procedures which are already formed within the organizations. And depending on the organization scenario, the security need, the even financial criticality of the locations, and other aspects, we do basically align our access security based on those things, right? Apeksha, hi, good evening. We are just revising the previous slides. And as the access security point come up, so we were just discussing how access security is critical nowadays, and there are some legislation which are already in place. Specifically in North America, you must have camera and access security with a physical card. It might be smart or non-smart cards, but still nowadays most of the company using smart card because of the low cost and the really good, great advantage of understanding the access given to a various different level also. So this is how the industry is being matured. This is how industry is being tackled. This challenges of physical security. Now there are logical security, which normally a very prominent point for each and every cybersecurity expert to understand the physical security as well as logical security. Physical security is also important. Most of the industry if you exclude the software industry, they have almost equal concern for physical as well as cyber security. And for them, well, we can see the apples and the orange there, but still at large, that's calibrated at a same level. And physical security is really easy to tackle. Like cybersecurity, we have so many threats, so many different point of entries. Physical security have a clear-cut understanding of so many gates, so many entries, and so many ways the physical security can be damaged, and we can easily tackle those things. So efforts to tackle physical security at much lower level, and the overall credibility which we get even in terms of cybersecurity expert, they're at a much greater level. So as a prominent cybersecurity expert, physical security is really important, easy to tackle, and we get quite a good ROI. That's how we say, right? Return on investment kind of scenario. So building physical security is also part and parcel of cybersecurity experts most of the time. And every organization feels so, even the legislation feels so. So we have to believe physical and cybersecurity as one scenario, and we need to address those concerns also with the greatest criticalness or concern, the way the organizations behaves. Again, this is also a regional phenomena, but in North America, it's considered as an equal measure. So we need to understand those things. Now, how do you configure, how do you monitor this security? We have seen about ACIM, then the platform security alerts, integration with different firms, managed security service providers, like even those security cameras and the other things, right? We normally get integrated those things and keep monitor those things also. Okay, so this is how the cybersecurity expert normally tackles the overall security requirement for a given organizations. So it's at we have also seen the hierarchy in terms of there's a global, regional, area level, and a particularly physical office level or physical building level security, which is normally tackled by each and every different personalities or different persons at times. And these are already being addressed by the organizational policies and procedures, the way they were tackling in the past. Okay. We also had a look at good SOC skill set, what we need in terms of what actually SOC is expected to do for organizations. We had a look at good, that 2.5 minutes video, which gives a good idea, right? Now let's go to a step further. Now we are going to understand good phenomena called cryptography. Now this is the favorite topic as far as overall interview concern. So these are you don't have to program it in a scenario, but you might need to discuss in quite a few meetings, quite a few discussion points. So that's why understanding cryptography is a need. There are hardly few types. Means I have jumbled up I think around 4 to 5 slides, which we'll discuss in terms of how we tackle these what I can say cryptography measures within our security gamut. Within our security area, right? So it's a need as far as the interview goes. Even if you don't remember, you can note it down on something like if you know those what they call typical cards or tabs, right? So you have these cards and keep it ready whenever you do interview. So even if you miss what I can say a point or two, you can read it from that card and start reading those things. That's how I normally suggest everybody to do, because it's good reference material, and these are really good old textual references we took, and that's how we normally try to understand or address this what you can say cryptography type of terminology which we use on almost everywhere. So yes, this is a kind of need we should learn. I believe for Shubham this will be easy, but because there will be a a good text paper whenever you're studying cryptography. But overall, otherwise, we have to remember these words. Let's try to understand the cryptography thing. Okay, the word cryptography contained by combining two Greek words. So the word comes from Greek. It's crypto and graphene. So it's like hidden text. Frankly speaking, that's how we try to. Okay, why do we need cryptography? Because every communication, as we see in the physical security, now we are moving to something like logical security. In logical security, we monitor the communications. So ingoing or outgoing communications are being monitored and basically encrypted most of the time, because all those secure requests which are coming to you, secure requests going out of you, we normally encrypt them. Why we encrypt them? Because these requests are proprietary in nature, or these requests are not open things to be shared with others other than the party which he or she should read, right? And so on and so forth. So we included something called ciphering the text or hiding the text, and that's how that cryptography terminology came into picture. So we are trying to tackle intangible security or logical security. That's how we normally address these security measures on a cybersecurity expert domain, right? In earlier, Romans, they started using this cryptography whenever they, transferring messages from one king to another, or, one military to another, and so on and so forth. So this way they have started building this cryptography thing. Okay. The first popularly noted, cryptographic communication was during Caesar's period. It's called Caesar Shift Cipher. This is, if you're really, this is really, great thing to read, frankly speaking. There are a number of novels written on cryptography. There are a number of various, good number of papers available even on IEEE site and, various other institutions site. So you can go and have a look at them. If you just Google cryptography and, or cryptographic thesis, cryptographic, there are quite a few number of movies also available on cryptographies. Okay, so cryptography is really good, what I can say, discussed parameter quite a few times. So as an cybersecurity expert, we should know what the others are being talked, and we should be able to be a part of the overall, this cryptographic discussions. We don't develop ciphertext for any of the program, so I'm keeping those things out of these things, out of our training material. But if you want, I can discuss those as well. And of course, whenever you do cryptography, it depends on platform. So for each and every organizations, the way they've developed or evolved within those platform, it depends on how their policies and procedures and form, how these, what are the tools and technologies they use in terms of communication with other, normally give rise to a particular cryptography being used. We'll have a look at number of cryptographies today, and we'll try to understand how this cryptography is implemented in a communication way, and how do we basically logically secure the outgoing request as well as incoming request, right? Just to understand from you, how do you basically describe communications within the server, or within the logical paradigm? When one computer talks to other, am I right? Or do you perceive any other communications for a given organizations? Anyone? See,
I'm sorry. Sorry, what was the question again?
Okay, how do you perceive a communication from office to office normally happens?
Through packets.
Right. Okay. So no. I was talking about more of logical level number of channels, like computers, phone, text messages, even the pen drive or outgoing storage media, incoming storage media, and so on and so forth. Yes, you're right. Basically, we normally have packets, and that's why we have something like HTTP, Hypertext Transfer Protocol, which is normally accessed via port 80, and a couple of other ports also, which are normally being configured for such communications. Now, these ports, whenever we transfer packets outside as a request, or whatever we get as a request, we normally try to read them. They read by server. They basically, what I can say, open up those packets. They try to, analyze the headers. Then they try to analyze the contents, and so on and so forth. The request is processed by the server. Normally, it's being handled by server level and other server level. Now, how the ethical hacker or the other hacker can think? They normally bundle something in those packets, which is kind of self-executable. That's the first scenario which we have, I think, tried to understand earlier. Now, whenever we have a packet which is contains something like self-executable, or what we call it binary. Normally, HTTP is designed for text, but then it basically migrated when it comes to HTML5 and the other media. We also include the streaming, what you can say, binaries via HTTP. Well, they create some separate channels or separate connection requests or separate streams, but predominantly we do have the initial request come through the HTTP. Now, whenever that initial request comes through as an HTTP as a text to initiate a binary pipe to be connected, right? I'm trying to keep the technology out as of now, whenever we discuss tool, we'll go to that level where we actually understand how that binary handshake happens, and then we'll go understanding the tools, however they are going to analyze it further. But for the timing, let's understand there's a text connection. First HTTP happens, the user is getting authenticated, and we create those sessions for the user to communicate and all. And within those sessions, if the user or the connecting request extend or start creating pardon me, start creating something like binary pipe. These binary pipe can have an executable within them, or we can build a software where we normally categorize the executable as a separate entity to be called. Even the compressed or a zip entity, we can channel it to separate pipes, or that those pipes are clearly marked. And specifically, the antivirus or the operating system does that for you. So if the request streaming is a bit different than executables. Believe me, we'll have a look at that thing. If you want, we can go to a header and content level also. So we normally segregate the stream, text, a normal streaming like video, audio, and all those things. And the third one is executables. So executables are the most crucial for us because they contain the self-executable or the command. If you really allow them, they can damage up to a great deal rather than the other two. The other two are hardly, comes around 1%, or if you want to me to go to it's actually calibrated 0.78% of the overall damage which have done in the industry in the past. So, look at the overall damaging scenario, or look at the way the criticalness of that executable stream being connected and being, started on terms of request basis. These details are available on IEEE site. So you can go to I3e.org, and if you go to security or cybersecurity, there are critical numbers or critical graphs available there, how cybersecurity is being targeted, tackled, and the efforts are being distributed in different these areas. We'll have a look at it. Even I'll show this thing at the end of our session, so that we'll understand. Whenever interviews coming on, I would really request you to go to IEEE site and understand these differences or change in numbers. Because if there's a person who is a cybersecurity experts, they are basically what I can say, normally should study these numbers at least once a week or once a month, because these numbers clearly gives you an idea which area to be tackled for a given even region wise, or even part of the year wise or the day wise kind of scenario. Like just to throw a sample, during Christmas, during New Year, normally there are these e-commerce sites are being targeted or being hacked, and the hackers try to basically get some revenue out of those targeting parallel stream and all those things also. So that's why we have a clear indication or clear industry study of where these hackers are normally or whatever these hackers normally target to for given periods or days of time. And that's really good to know, because this is how the industry is being analyzing it. So as an analyst, it gives me a good heads up, good starts up, right? So that's why we target these things. Now coming back to our communication. So all these logical communication, the executable are the most critical ones, right? Now these cryptographic standards, they are normally used for the text based systems, and even if they get it compressed further, they normally use cryptography in hiding those zip files before compressions. So this is how this normally cryptography is addressed. For binary stream, we are basically trying to build a good compression mechanism as well as encryption mechanism, but still it's not that clear, or it's not that industry standard as of now. So be it something like YouTube, be it something like MyTube and all those other video supplying these things, the stream are still quite open whenever they are communicating between two different computers, and that's how they are trying to have these a compression mechanism more importantly rather than encryption mechanism, and that's how industry is working. So if somebody asks you what do you know about video encryptions, we can clearly say video encryption is basically proprietary in sometimes, but it really damages the efficiency on a greater level. So we normally stay away from it, and we try to compress it and encrypt it to a very basic minimum level, like byte shift level or something like that. And that's also kind of at a header or at a very crude level rather than going into in-depth encryption like we do for text and all. So normally encryptions are addressed for text streams. So the primary request streams, the session handler sharing streams, and even the text content handling type of streams. Like if you have a crucial web page coming to your way from a really critical site where it need not to be handled by any other or need not to be read by any other than you, then we have the highest level encryption on such scenario. Like even for that matters, the banking transactions and the e-commerce transactions are the most encrypted as of now in the given cybersecurity industry or cybersecurity area. And these we address at a greatest level. So we normally target our cryptographic for these two streams, the text streams and the compressed text streams, and that's how we normally use cryptography. So this is the utilization of cryptography. Have I started recording? Just give me a minute. I do, keep forgetting those things. Yeah, the recording is going on. So this is how we tackle cryptography. Now the first, Caesar shifts cipher, you can clearly see on this image, right? So that A is being, replaced by C, T is replaced by V. How do we do it? We shifted the 2, we added 2 to the A. If you know ASCII, right? ASCII. ASCII for A is 65, for C is 67. And that's how these ASCII communication happens on a textual basis. It's get converted to the binary whenever, or hexadecimal whenever to computers talk. But normally what we do, all A's are converted with C, all T's are converted with V, and so on and so forth. So we shift the text by 2. So whenever somebody try to open that package, he'll read, like C, V, 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 C, E. That doesn't mean anything on a generic world, or that confuses the reader and he can't basically read whatever the message has been sent. Right? So we are trying to hide communication in a simplest possible scenario, which doesn't require too much of efforts on a sender level as well as on an access level. Only that number 2 is basically to be known from the receiver end so that he can decipher or he can decrypt the text which sent to him. Is it easy enough to understand? This is the basic level of encryption we are talking about, and we still use these things in quite a few way. If you want to have something really encrypted going on between you and your friend, you can have email also done with this, and it's really easy to do. There are quite a few number of tools available as far as the email being cipher texted. They call it cipher text. Well, the basic name is Caesar shift cipher and blah 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 stuff, but actually it's called just cipher text cipher text markup or cipher text encryption. Simple, right? Let's take a step further. Okay, what was this? Okay, now let's try to understand modern cryptography. This was, as we know, Caesar's period. What is I think late 1600 or so, right? And now we are almost around 300 years after. We have enhanced those things up to a great level, right? Now modern cryptography, it operates on a binary bit sequence. These texts are being converted to a binary where we normally encrypt it to a great level. So unless and until you know how it encrypted, you couldn't decrypt it. And of course there are nowadays levels of decryption also. So there should be a level of encryptions, right? So let's take a deep dive in terms of modern cryptography. It relies publicly known mathematical algorithms for concealing the information. So we are trying to hide the information with a good help from our mathematical experts, and we build an algorithm. So even if you're deciphering a text, we might change for first 2 lines 2, for next 3 lines 5, and something like that. So life gets complicated for these hackers. They couldn't decipher it because he'll go with simple ciphertext. So I got first 2 lines, then I couldn't get the next 3, so I couldn't read the complete message, right? So something like that. So we're trying to improve the secrecy step by step, right? So secrecy is obtained through a secret key, which is used as a seed for this algorithm, right? In cipher scenario, we have those 2 which we've taken for example. In others, as I told you, we can have a multiple level in terms of first 2 line or first 3 line with 2, next 3 line with 5, and so on and so forth, right? The communicational difficulty of algorithm, absence of secret key, make it impossible for attacker to obtain the original information. Now again, let me share criticality here. As we get matured, even the hackers get mature, right? So they will invent a way to get those key from somewhere. So whoever decrypting it, the key can be leaked out in a number of ways. Might be I get friendly with that person who is decrypting, or cybersec analyst working at my sender, and he might giving a bribe or something and try to find out this way. It happens. Even if it's multiple level, this is the best way of hacking the senders decryption methodologies, and build those decryption methodologies within yourself whenever you steal those packets from a typical HTTP stream, right? And so on so forth. This is how it happens actually for a given hacking purpose also. But now we can go a step further and trying to have parties interested in a secure communication to possess the secret key only. So what will make sure whoever is encrypting can be a machine, right? We can create a program to encrypt, and we can create a program to decrypt, and these two programs can talk on a separate level. Might we use some another channel like HTTP, we use some cellular network channel to try share this key, or an email. So these are two different communication streams where one machine is talking to another and trying to share those encryption key, or trying to share those decryption type of strategies which we've used for encryption. Are you with me here, or am I talking too technical? Come on. Could you understand what I'm trying to say here? Any confusion in understanding encryption and decryption?
No.
Yeah, good, right? Well, chalo, let's take a step further. Now, what's this? Definition. Let's try to understand cryptography as a definition, and this is really a need because normally, if your interviewer is Indian, he'll definitely ask you this. Ask you this definition. So either you need to write it down somewhere, or just try to revise it before the interview. So if he asks what you mean by cryptography, you can tell them these sentences. And these are basically IEEE standard definition. It is the art and science of making crypto system that is capable of providing information security. So what is cryptography? It's an art and science of making crypto system that is capable of providing information security to a given communication, right? And this goes on. Cryptography deals with the actual securing the digital data. Well, yes, of course, I missed that point. Okay, there are two type of normally data to be secure, right? One in communication and one at storage. One at storage, basically, if you talk about something like Oracle database or MySQL database, now there are a number of open system database also, and on top of that we have something called big data also. So what is big data? It's a decentralized database, right? Now let's talk about a simple scenario. And yeah, now if you look at the industry, quite a few number of IT companies, or bigger companies which utilize a large number of data chunks, they are moving to the big data thing because it's efficient. It's really good to have data at a different server. Even if there are one or two failures, it doesn't really damage the overall streaming or damage the overall data communication. So that's why we have a separate centralized database kind of systems, right? So these data system also need to be encrypted because some hacker might steal some information and can be used against us, right? So something like that, sir. So cryptography deals with actual securing of all digital data, be it in communication and be it at storage. So these are the two scenarios which we need to describe whenever somebody asks us about cryptography or the data to be secured for a given scenario. It refers to a design of mechanism based on mathematical algorithms that provides fundamental information security services. So nowadays, mathematical algorithms are the common ways and means to do encryption, and that's the kind of generic statement. There are ways and means of different algorithms to be used. Even ciphertext is an algorithm. What is algorithm? Algorithm is repetitive things which we use to make our life easy. So those scenarios. So ciphertext is an algorithm which we use to decrypt our say outgoing message or stored data or something like that. So you can think cryptography as a establishment of large toolkit. Again, cryptography as a establishment of large toolkit containing different techniques in a security application. Now we are talking about multiple techniques. Why? Because as and when we grow, as and when we learn, we have to improve our security step by step. How do we do it? We do it with improvement of these toolkits, improvement of these communication methodology, improvement of this encryption methodology on a given level. So if you are using really critical data, which no way shouldn't be perforated or accessed by anybody else, what we do, we tend to build much larger level of securities, or we take security to a level where it is really impossible to decrypt, right? And so on and so forth. So we improve our security levels or improve our encryption levels to improve security, and that's how we implement it, right? I believe you can tell this thing, right? You can spell out the sentences which I'm sharing with you now, and these are really important in terms of whenever somebody asks you about cryptography, in terms of definition, in terms of environmental analysis. How do we do cryptography? You might not need to discuss any tools as a specific tools, but still you need to understand the concept overall and should be able to share it during the interview. And these are the most favorite questions of the interviewers, because this basically lays down a fundamental for all the communication happens digitally or a storage happens digitally. And as far as in the area of such digitized world, this is really critical for each and every organization to understand cryptographic as far as every cybersecurity goes, cybersecurity expert goes, right? So that's why we are spending some time on understanding cryptography on a larger scale. Okay, the cryptographic process result in a ciphertext for transmission and storage. Now, ciphertext is a very generic terminology used by quite a few, cybersecurity expert. But normally, the way I feel it, the way I typically feel it, ciphertext is just the cipher encryption, whatever we seen, like adding 2, 3, or 5, which is basically used for a primitive type of encryption. And we have quite great number of difficulties in even encryption processes also. We'll have a look at a few of them today, and we'll try to understand how this cryptographic thing really make sure if anybody other than the intended party try to crack down your code, try to crack down your storage or the digital communication, he or she may not get a character out of it, which is really relevant to the communication. And that's the intention of the cryptographic communication terminology. So cryptography concerns with the design of crypto system, while cryptanalysis study the breaking of crypto system. Now, cryptanalysis is basically analysis done to decrypt the messages. Wherever you don't have the exact number of tools known or exact number of way known to the decryption methodologies. Could we understand this sentence? Cryptography concerns with the design of crypto system, and cryptanalysis or cryptanalysis studies the breaking of crypto systems. Are we good? Have we understood this terminology? This is basically used whenever during the communication or interview to let you baffle in terms of this cryptographic understanding. And a good interviewer might ask you this question: tell me the difference between cryptography and cryptanalysis. How it differs? So cryptanalysis is not just analysis. It talks about how you're going to use or trying to understand the tools as well. It's not just the analysis; it's knowing the tools as well. So it goes to a kind of deeper level than just analysis, but still refer as an analysis. Are we good? Are we clear? Or do you want me to explain again? Any confusion at this point? This is the first level of cryptography we are going to learn. Apeksha, Shubham? Yeah, please go ahead, Shubham. You were trying to say something?
No, I said I was saying that I'm good.
Okay, so good, right? There's no challenge in understanding.
No.
Okay, great. I'll take same with Apeksha as well. So let's say now security services of cryptography. So what we do in cryptography, right? We understood what the need is. Now let's say what we do it. So we're going step by step, and then we'll look at the ways and means of how do we achieve this. So let's try to understand what we do this in terms of services of cryptography. So we do data integrity checks. Now whenever you encrypt something, right, it shouldn't get damaged the content, right? So for that we have to have some certain mechanism, certain policies and procedures to make these in a disciplined way, rather than Ravindra is doing something else at his home, Shubham is doing something else at his home, and then the encryption decryption process is really ad hoc or hazardous. So we might lose some content, we might gain some, and so on and so forth. So for that, what we do, we build some services in terms of we need to make sure the data integrity is maintained throughout the communication, with the encryption and with the decryption also. So whatever message is being transferred is transferred, because this is the means of transferring a messages with the what you can say, with encryption, right? So the process shouldn't damage the content. That's why data integrity is the foremost and the most important part we need to consider whenever we are trying to address this encryption or decryption process. Let's try to understand from a technical standpoint. Come on, let me. Okay, now it is a security service that deals with the identifying and any alteration to the data. So we need to have certain type of mechanism by which we depict that this data is being encrypted. This data is being sent as an encrypted data. So whoever receives it need to understand these encryptions have certain ways and means to decrypt also. I'm not giving the exactly means, but I'm trying to put a flag on my data saying this data is encrypted. And this is the generic terminology. Yes, this data is being encrypted. And that's how we communicate. The data may get modified by an unauthorized entity intentionally or accidentally. Yes, these do happen. What we can say, packet corruptions, right? You heard of packet corruptions? So this packet corruption, how does it happen? Due to certain communication challenges or electrical interference, magnetic interference, and so on and so forth, the data packets might get damaged by a byte or two by itself, and it do happen. So whatever that checksum we have while sending and receiving, which can understand those damages if it happened at all. To add to that, there is a timestamp goes with each and every data packets, which clearly mentions if the data packet is bundled and delivered. So how this data packet is being communicated from A to B, and what is the what is the timestamp for encryption, what is the timestamp at decryption, and if there are any timestamp entity added in between, can get notified by the receiving end, and so on and so forth. We do a checksum on timestamp, we do a checksum on number of bytes sent for each and every packet, and that's a normal way the HTTP protocol has been developed, or the overall internet protocol have been developed, right? So this scenario, we make sure the data packet is not damaged in between, and that's how we make sure whatever data packet is received by us is completely packaged well. Simple, right? Now integrated services confirm whether the data is intact or not, since it was last created, transmitted, or stored by an authorized user, right? So we normally do have session information which can give you a critical information like who, what time, till what time, and so on and so forth, right? So for those session environmental variables, we can retrieve those information also. So this is how the traceability works for a given data integrity, right? Now, data integrity cannot prevent the alteration of a data, right? Now we are talked about the packaging of the things, right? Like we order some food from Swiggy or Zoom. In India, we had these challenges, right? The executive which used to bring food to you, were eating quite a few items within those packets, and then they used to seal and then they used to deliver. So if you order a pizza, you might miss a slice in that. Now, when you find out that, you report to those entities saying, "Hey, boss, you given me pizza with just 8 slides, 8 or 9 triangles than the 12 or something like that, right?" So on and so forth. So this is how it works even in data integrated type of scenario. So if I have a storage of data, let's say it's MySQL storage, and if I find certain junk missing or corrupted, what I do, I'll try to build the integrity again with the tool present within the database services. Okay, and this is how to. On top of that, I do an audit if the authorized user or do have the session reference variables corrected for such storage or updation of those data. And these are the services which are included in the database from quite a good number of years now. So they are matured enough to tell you if somebody accessed the data, when, what time, and logged in from what to what time, and so on and so forth. So we have all session related information for the database, which is a kind of necessary information for each and every database. And this is how the data integrity is checked out. Okay, any difficulty in understanding data integrity? Have anybody gone through such scenario where the data integrity has been compromised anywhere? Could you share your experiences if you have any? Anybody worked as a data administrator? Shubham, Apeksha?
Sorry, what does what?
Have you worked as a database administrator anytime?
No.
Okay. Otherwise, a data administrator normally get a logs of integrity exceptions logs. That's how they call it. And these normally have the session variables wherever if somebody try to access the database. Like if you key in, wrong authorization, authentication, like wrong username, password, the session records. Session also records your IP address and all those things. This is a normal way the database works. Even if it's big data or Oracle, MySQL, MS SQL, and so on and so forth. So for these type of database, they normally have these logs called data integration log, and you can pull it from a server if you are an administrator. That's why I asked if you are. So this is how we monitor the data integrity. We monitor these database integration logs or other relevant log. They could be renamed as something else also. But on a larger scale, what we're trying to understand, we're trying to understand if somebody is trying to access those database with wrong credentials and what time, from which machines, and so on and so forth. And that's how we do it. Okay, so this is about data integrity. Any confusion on data integrity? Anything you want me to describe in depth? Oh man, what happened? I take it you understood, right? Can I go ahead?
Yeah, I'll just confirm it once, just to make sure that I understood it right. So data integrity basically means the contents and the information, whether it's a file or a package or whatever it is, it should have same attributes and same properties as when it left from the source, right? Any changes in the metadata or its attributes means that the integrity has been compromised.
Perfect. You basically talk like an engineer. That's really right. In those many words, very rightly said. Means I was talking mostly non-technical stuff, but yes, you explained perfectly fine. That's great. Sure. Let's take a step further. Okay, now talks about authentication. Now, what is authentication? These are the credentials which allows the users to access those data, be it a store data, be it a communication data. So if, let's say, Shubham send a mail to Ravindra saying, hey, Ravindra, we need to meet at such and such place, and I'll hand over such and such documents to you, which we both feel like very, sensitive information shouldn't be read by anything else. Now, I'm just trying to send an email from one to another, a message, or let's say a message. Say Shubham wants to WhatsApp me certain documents, and he wants them to be make sure only I can access those. Okay, let's take an example of WhatsApp. Now, Shubham has WhatsApp, he logged in and all those things, he has his credential. He also has Ravindra's number, phone number, and how it can be communicated via WhatsApp, and the contacts added and all those things. So these two users are connected. Now, when Shubham sends a message like, hi Ravindra, I want to send some critical documents to you. Can I send it to you right now? I'll say, okay, yes, definitely. What type of documents are you sending? So you talk about document of sending, and then you try to send, let's say, Word file or a scanned JPEG via WhatsApp. We have sent, right? So it's not that difficult to understand. So whenever I send a Word file via WhatsApp, Nowadays, I think for the last 3 years or so, WhatsApp are using encrypted mechanisms to send from one user to another. So even if Shubham sitting in North America and Ravindra sitting in Mumbai receiving those documents, those are encrypted at Shubham's end on a Shubham phone and decrypted at Ravindra ends on Ravindra's phone. Now, let's say Ravindra sign in through laptop or desktop. So whenever I sign in through laptop and desktop, now there are two delivery points for a single entity, which is shipped from a sender. Now these two entities should have the decryption mechanism, as these two are all already authenticated or authorized. Now, have you seen this do happen? So my decryption at mobile is also incorporated by the decryption at laptop or desktop, wherever I sign in as a WhatsApp this thing as well, right? Now, but that's not the scenario with WhatsApp. Let me take a step ahead and try to explain you this thing. What WhatsApp does, WhatsApp copies your WhatsApp on the phone on a desktop. It doesn't basically have the decryption methodology which you have on a phone on your laptop. It just copies the data. It just creates a mirror stream rather than a parallel stream. Could you understand the difference? Mirror is mirror to this communication, and parallel is I'm having this communication and there are another channel. So there are no second channel is being created by WhatsApp for this. Why this is important? Because WhatsApp don't want to create another authentication mechanism at another level. So what it uses, it replicates the authentication mechanism, or rather decrypted data to be mirrored on certain other device. So if this phone is not working, your desktop thing is not working. You might have experienced this thing, right? Have you experienced these things? If you keep your phone off, your desktop WhatsApp couldn't access the data because that mirroring have been already removed off, and this is done by near about to be precise 2019 October they started implementing that. Now it's implemented worldwide. So whatever the encryption you're implementing has to have addressable to the issue strategy inbuilt in that, and that's how it works. So when you talk about authentication, these are the critical matters. So whatever decryption key has been supplied normally shouldn't be supplied multiple times. They are supplied at source and destinations only, not to any third party. But it was a pitfall previously with WhatsApp, and that's why they couldn't, basically deploy the encryption worldwide. Now they have improved it and they have deployed it. So this is how even authentication, and this is how it differs from the integrity. Well, it maintains the integrity, but still, whenever you're trying to decrypt, you have to have a single source, a single entity which decrypts rather than multiple entities worldwide. Because the mechanism should know how to decrypt, and we shouldn't have too many receiving parties to a single sender. Could you understand me? Too many receiving party to a sender can create security pitfalls. Or I might need to, as a receiver, also make sure as a sender also, make sure the receivers, whoever are receiving, are completely leakage proof or threat proof and all those things. So the entity which is sending, the responsibility is in multiple, and we don't want that. So whoever is receiving it should make sure whatever you receive is decrypted at a level where we can clearly see that decryption happens only at one place with only one authorizations and authentication in things. Similarly, with the emails, well, email is with have its what we call email is a kind of smart client rather than a typical a mobile communication type of scenario. So for email, we have better security measures, and we'll discuss that some other time. And but WhatsApp is simple to understand. That's why I've shared those kind of case study with you, as well as WhatsApp security improvements within last few years are concerned. You can share such information, and you can have learning about WhatsApp encryption even on WhatsApp servers also. They have a site, and I think in the help section or I might share a link with you. Don't worry on that part. So they have given these details with the workflows and clear depiction diagram at that level. Okay, so let's try to understand authentication. Oh, come on. Okay, let me change the size of it. Okay, yeah. The authentication, the authentication provides the identification of the originators, and basically, oh come on, originator, it confirms to the receiver that the data received has been sent by an identified and a verified sender. Now, this is kind of verifying the sender and the receiver at a level where the data integrity has been addressed already, and then we, at another level, we address the authentication and authorizations issues as well, right? And this is how we basically try to make sure whatever services are be given for the cryptography have been checked and balanced at sender and receiver end, right? Let's take a step further. Now, just to go in a step deep on our authentication services, we have to check authentication on multiple levels. So there are something like message authentications, entity authentication, and non-reputation. Let's try to understand these three. These three are really important in terms of understanding how the messaging works on a protocol level or on a port level, right? So message authentication, it identifies the originator of the message without any regard to a router or a system has sent the message. Okay, now let's try to understand a packet originating from North America coming to India. Now, North America, let's say a person sitting in Irving, Texas, who sends a packet to Ravindra in Mumbai. So whenever he sends from his home internet or cable net or whatnot, he creates a message saying, "Hi Ravindra." Now this message reached to his Wi-Fi router, it reached to its central hub within those area, and then it puts onto the internet highway. It shipped to India Internet Highway. Then the India Central Internet Server and hand it over to the local router, regional router, then to a regional router of Ravindra's home, and then to a desktop of Ravindra. So this is how the overall packet has been transferred. Now, why this is important? Because the routing also gives you a clear idea like what type of area the packet has been traveled to. So if the packet is being traveled, well, this is not the normal scenario. The packet might travel to North America, Middle East, Europe, and so on. So forth. There are a number of destinations normally, or a route it took, right? So why this routing is important? Because we might ignore the packets coming from a dubious routes. Why dubious? Because there are some there are some areas which we believe we shouldn't route our packets to, and these are normally managed by the routers at North American end as well as India end. When North American router means the internet router which sending packet on internet highway, trying to categorize these things, there are routes which are normally selected for a given destinations by default. And this is how these, well, the routers are also computers, right? They have certain packet routing information within themselves. These are normally multi-processor-based system which have a domain forwarding informations with them. So one domain to another domain. Now, specifically router used to work with HTML3 and so with a numeric IP routing. After that, we normally go to the alphanumeric IP routing where we try to basically take the what you can say secure route rather than efficient route, and we are being increasing the bandwidth as well as these internet highways are concerned in leaps and bounds. So now I can use more secure route than a efficient route. Efficient route can be just pipe the data through the any region which comes between. So it can be a straight line between Irving, Texas, and Mumbai, and that can be the shortest possible route for a given packet. Because electronically, well, there are a number of routing channels available on that route, and this is how we do it. Okay, but whenever we move to HTML4, HTML5, we started planning this route on a more secure level rather than more efficient level. So the priority have been changed. So all these packet routing is important. But whenever we authenticate the message, I need to just check out if it's coming from Irving, Texas, and with Shubham's name on it. Something I'm just taking, a raw example here. Now, for these type of methodologies, we normally try to even segregate the computational model of decrypting and encrypting also. We are trying to make it more efficient at a sender level and as a receiver level also. Specifically at a receiver level, sender is okay. Sender has just one or two tools mostly to encrypt and ship it to a router. But at a receiving end, we need to understand those tools. We need to understand their version. We need to understand the attributes being added to the encryption, the levels of encryption, and so on and so forth. So at a receiving end, the encryption is a bit critical entity than the sending end. So at a receiving end, there are these number of different levels we use to decrypt those packets. First is message authentication. Is it sent by Shubham from Erwin, Texas? Yes. Is it intact in terms of checksum, in terms of those timestamp? Yes, check. No, reject. Ask for another packet. And this is how it happens at a message authentication level. I am just checking couple of things and each and every entity level so that the decryption is also an efficient service. The service shouldn't overcrowd the communication. Are you with me? The delivery of a code shouldn't overcrowd the things which we are delivering. So that's how we need to make it efficient. How do we do it? We do it in segregated authentication and authorization services like message authentication at level 1, entity authentication as level 2, and non-reputation at entity 3. So let's try to understand. Have you understood message authentications at this point and how do we do it? Any confusion there? Are we there? Shubham, Apeksha?
Yeah.
Okay, great. So have you understood message authentication?
Yeah.
Okay, great. Sure. You might have have this covered in your normal course also basically, and you might have this thing in quite a good number of depths also. So let's try to understand. So message message authentication, we clear out the identifier, we clear out the checksum. That's all, these two things. Then the entity authentication is the assurance of data have been received from a specific entity, say a particular website, say a particular channel. Now we are trying to address those things which are going a step further, trying to ask or trying to what you can say, extract this information from a given packets or number of packets. Okay, so these basically talks about specific entity, say a particular website. So is it generated from a particular website or particular sender, particular router, and so on and so forth. And that's how I try to understand the entity authentication. Apart from the originator, the authentication may also provide assurance about the other parameters related to data, such as date and time of creation and transmission also. Okay. So, sorry, the timestamp has been verified at an entity authentication level rather than message authentication level. My bad, basically. I included that thing in message authentication. So, message authentication is just the identifier of a originator and overall the integrity of the message. That's all. Entity now talks about the timestamp and overall understanding the other attributes like how the packet has been transferred to the destination. Now let's talk about non-reputation. The property is most desirable in situations where there are chances of dispute over exchange of data. Now let's try to understand these things. Wherever when Ravindra says, "Hey Shubham, I received a request from you for submitting my financial records to you," and Shubham say, "No, I never sent that thing." This thing do happen in a normal business. So how do I make sure Shubham has sent that request or not? There's a non-reputation entity in an authentication service where I can leverage those details from the package sent to me and try to extract such information. Like an order placed electronically by a purchaser and refusing to pay for it, saying I have not placed that order. There are some information which is collected for such entity, for such request by the services indirectly from the sender or from the person who is putting that request. Now this is what we call non-reputation or you can't really deny that you send that information, because there are certain data or attributes collected by the entity, by the system, from the sender's entity, and that's how this clause works. Okay, so these three things: message authentication, entity authentication, and non-reputation, make sure whatever is being shared by sender and receiver is validated, verified, and proved beyond doubt. Proved beyond doubt is through this non-reputation clause or non-reputation services of authentication services. Are we clear on this? The next step,
Yeah.
the next step to this is basically going into the programmatic level. Okay, if you need, we can go, but I kept it as light as possible as of our training. Now let's try to understand these three, how it works on a logical level. Okay,
Once.
good, good. Go ahead, Joe.
Yeah. Would you be able to explain the non-repudiation part again?
Sure, no problem. I'll do that. Just give it.
Thanks.
Okay, non-repudiation basically talks about the sender saying, "I have not sent this." Might come to might came to you from different sources, but I'm not the person. Or somebody use no, let's not go there. So I'm not sent it. So how do you prove that he sent it? There are certain mechanisms which we build in this communication, saying whenever Ravindra places an order, it tries to basically collect enough information even to prove that thing in a court of law. Believe me, even to prove that thing in a court of law is the critical matter here. Why court of law? Because Ravindra can come and say, boss, I have not put an order for that entity because now that entity has gone cheaper. This is mainly happens in an import-export kind of business, where Ravindra importing something from North America to India. And then Ravindra says, boss, I have not ordered that thing. So then the sender entity can go to a service provider saying, please give me the non-reputation attribute details, and I can present it in a court of law. Literally, that's how it works in even legal matters. So these non-reputation things or the attribute make sure or proves beyond doubt if the sender is correct or the sender which we are talking about. And this is really improved during the HTML5 or the latest internet version 4 and onwards, because this non-reputation is crucial to many legal systems around the globe now. And these clause make sure whoever was a sender, his identity is captured up to a level of beyond doubt. There is no doubt if Ravindra placed that order, if Shivam placed that order, or so on and so forth. And that's how we have these non-reputation attributes or added to the authentication services whenever we are improving these internet communications. Or even in storage also we have non-reputation. So if Ravindra updates the database, say if he logs in the night 2 a.m. and try to update a database, even if it's a big data or a crypto data, well, cryptocurrency works in a bit different way. We'll have a look at it in case if we need it. But otherwise, the database has all these non-reputation clause embedded into it. Basically, the problem with cryptocurrency is non-reputation clause or the way they're tweaking it. And that's how the problem started, initiated. But if you look at typical database, they have these reputation services inbuilt whenever somebody tries to update the database. That's the core engine of a database. Means if you update anything, let's say even in a big data or MySQL, MS SQL, or any database, the reputation attributes are being captured and stored whenever somebody updates the data. So that's why there is a reading service, there's the updation service, there's a modification service. These services communicate very differently when it comes to a typical database or data stored mechanisms. Have I cleared your doubt, Shubham?
Yeah, but I'm still confused as to, like you mentioned, that they confirm the identity of the buyer, right? So how exactly do they confirm it? Like, what things do they collect in order to confirm their identity?
Okay, that's a really great question. Now we need to go to a programming level over here. Whenever Ravindra goes to, let's say, Amazon, right? And as I know, Putting order in Amazon is really easy if you are doing it from a PC where you are registered. But if you're not registered with Amazon and you try to place an order, try to do that. Means take a phone number or take a phone where we don't have that Amazon services calibrated for yourself, and try to put an order and try to understand what are the extra information they are collecting from you. Forget about they know your packet originator, they know your router and all those things. Out of that, they try to basically give you an OTP also, which is sent to another communication channel like your phone number. So they're trying to build a traceability to you programmatically, so that even if you refuse, like I have not done it, they have enough data in the legal code, which is a non-technical system, right? Our legal system is not technical, be it in North America or even in India and most of the worldwide thing. So even you can prove those attributes to a level where they can prove your identity beyond doubt for these type of scenarios, because these things do happen in the past, and then need to make sure these challenges have been addressed to a great level. And in some scenario, wherever, even if Amazon, they stopped delivering you if you falter the payment or if you reject the receiving of the entity a couple of times. They do that. In India, there are certain regions where Amazon stopped delivering, specifically in northern UP, where there are frequently, I have not placed the order kind of scenario, and which is, related to the political parties and all. So even the legal system doesn't effectively work there. So those kind of scenario, Amazon have almost stopped the, delivery of such order. So if you log in from such zip codes, you might not able to put the order or process your order. Believe me, this is really happening. And similarly, if you go to some South African countries, there are some countries which are normally not, what you can say, or they are marked as a non-delivery zone by such e-commerce entity globally. I can order something from North America, being in India also. I have to pay those, all those forwarding agent charges and all those things, which are basically adding at that custom code now. But still, I can. But if you go to certain country in South Africa, I can't order anything from North America or certain region, or the Amazon doesn't deliver there. Or you need to go to a level where you need to prove your identity first for receiving it. Forget about the sending party, because that's how we build this non-reputation clause. If we can't build it digitally, we try to build it by other means, like physically or something like that. So, and that's how the e-commerce entities also make sure that non-reputation clause is completed as it's being forced in by the legal entities across the globe. The law and order systems, frankly speaking. How it done? We'll have a look at it in depth. I might share a couple of videos if you want to, really read on these things. I think we can learn in depth on that basis. But I don't want to go to a programmatic level. But on a larger scale, have you understood what the non-reputation clause is all about?
Yeah, I mean, I understood the concept. I just wanted to know like how exactly it works.
We'll see. Implementation we'll see. No problem. If you want, we can have another, one-to-one session and go in depth on non-reputation. It's really good clause. And this is the most critical in terms of nowadays because of the e-commerce entity or, mostly banking transactions, be it something like Swiss Bank, right? They don't disclose the identity of a receiver or sender to the general public. But for them, they need to, right? Means otherwise, how can I know if Ravindra Pandey have, well, I don't have account with Swiss Bank, but it happened with a couple of political leaders in India in past. After that, they have really, big number of challenges of accessing their bank accounts. And then they basically updated the means and ways to acquire that non-reputation thing by themselves. This is a need of the hour, frankly speaking. And that's how we have included in our authentication services. Okay. So let me stop you here, and we basically, go into depth. If you need, send me a message and we can go over it. Please, because it's not a need as far as cybersecurity expert as of now for a general public. So that's why I'm basically restraining myself. I like to understand these communication improvements, evolution also, and that's why I normally read to various research paper available on IEEE, various research papers available on even IBM and other e-commerce sites as well, where they have gone to a lens of explaining these things to the participants also, because that's how they generate the analysis or the manpower who are really interested in delivering their services in these areas. And believe me, there are some cybersecurity experts who basically specialize in this non-reputation fraud. These are called frauds because this is a legal entity. This is not a request originated from security expert, but from a legal entity. And that's how we incorporate in our security services. Okay, so let's take a step further now. Cryptographic primitives. Now, as the name says, we are trying to understand the evolution or the overall, the way we build this infrastructure specifically in terms of in terms of building our security services or improving things day by day. Let's try to understand one by one. We had a look at encryption. There are something called hash function also. We'll have a look at it. There's something called message authentication code or MAC, and there's something called digital signature. These four things are really critical in terms of building the overall cryptographic infrastructure around our communication. Now, these are specifically talk about communication rather than storage. For storage, encryption is more than enough. Encryption and the other services which we see in these data integrity and authentication services are more than enough because storage is sitting idle at one place or in a distributed scenario at multiple places. But if you look at the communication way, we need to understand the primitive on another level, and this is how we do it. Okay, we'll have a look at each of these entities on a bird's eye view kind of scenario. Like, okay, let me play a video for you, which really tells you. It's a small video which takes about how this key encryption works or the combination works at a given level. Okay, let me try to play that video for you. It's a symmetric key, right? So symmetric key encryption.
In this video from IT3 training, I will look at the two phases.
Now this talks about something like active directory scenario, but it's just an example. So it goes for length and describes the others as well. So let's have a look at this thing. Oh, come on.
I will also look at how these two types of encryption can be used together in order to improve performance and security. These fundamentals will help you deploy encryption. Your understanding of how certificates work. In today's environment, encryption is an important part of computing. In order to keep your files secure and have secure communication, you need to use encryption. Encryption is the process of taking data and encoding it into a form that cannot be read by unauthorized people. There are two types of encryption schemes that are used. These are symmetric key and public key encryption. First of all, I will start with symmetric key, as this is the easiest to understand. Symmetric key encryption uses the same key to encrypt data as to decrypt data. This generally makes it faster than public key encryption. The problem with this method of encryption is in order for data to be decrypted, the key must be available. This causes two problems. The first problem is the key needs to be stored securely. If an attacker were to gain access to this key, they could decrypt any data that key was used to encrypt. It is common for symmetric keys to be stored in a safe place and only accessed when required. The next problem is if another party needs to decrypt the information. In order for this to occur, a secure channel needs to be used to transfer the key. For example, a common practice is for the key to be transferred using the telephone. Public key encryption uses two keys, a public and private key. To illustrate, imagine that two people want to communicate with each other. In between them is a third party that is trying to eavesdrop on their conversation. With traditional encryption that uses the same key, the problem is getting the key to the second party without the third party obtaining the key. With public key encryption, the public key is required to encrypt traffic, however, it does not need to be secured. If a third party were to obtain the public key, they would not be able to decrypt any data that was encrypted using it. In order to decrypt the data, you require the private key. The private key needs to be stored securely, but the advantage is the encryption can occur without the private key. This means the private key never needs to be transferred, and thus there is no chance that it can be intercepted by the third party. You may wonder exactly how a system like this can work. The mathematics behind it are complex and beyond the scope of this video, but I will give you a summary of how it works. When data is encrypted using the public key, it is done in a way where there is a large number of possible solutions available. In order to decrypt the data, you would need to test every single solution until you find the right one. Although possible, depending on how big the key is that is being used, the process could take 100 years. If you have the private key adds enough information to the puzzle so that there is only one solution. It is kind of like having a prize behind a series of numbered doors. If you know which door the prize is behind, it is easy to find the prize. Without this information, you are forced to try every door or choose one at random. Public key encryption is generally slower when compared to symmetric key encryption, and thus, even though it has advantages over symmetric key, you will find, for reasons of performance, symmetric key will be used instead of public key encryption. Like a lot of things in computing, it comes down to a trade-off between performance and security. In order to get a good mix of performance and security, it is possible to combine public key encryption with symmetric key encryption. In some cases, public key encryption is used to exchange keys and symmetric key used to encrypt the data. The principle is that a strong algorithm with a large key should be used to encrypt the key. Public key encryption is very useful to perform key exchanges securely. Once the key exchange is performed, another encryption algorithm can be used that is faster and uses a smaller key. This could be another public key encryption algorithm or a symmetric key algorithm. The next use of public key encryption with symmetric keys is to protect the symmetric key. Encryption, like Windows file encryption, uses a symmetric key that is stored in the file. To protect the symmetric key, it is encrypted using a public key. This gives you a fast algorithm for encrypting files and keeps the key safe. Encryption systems like BitLocker use similar methods. This is why when you reformat a computer or delete a user, you may lose access to encrypted files. The new OS or user does not have the private keys that were associated with the user or OS that are required to access the symmetric key. For these reasons, symmetric key encryption is often used when performance is required. Public key encryption is used when you do not want to have decryption occur without the private key. You will find that some systems combine the two to give multiple users access. For example, Windows file encryption uses a combination of both encryption types so that multiple users, including recovery users, can access the symmetric key. When multiple users require access, the symmetric key is simply encrypted multiple times with each of the public keys required. It should be pointed out that either method can meet the needs of data encryption and communication, but combining the two does give a good trade-off between performance and security. Thanks for watching.
So now we are just, we were just trying to basically understand how this encryption, decryption used by industry, and how they are planned, frankly speaking. And okay, here we are. So even to compare it, basically how these services are being used. Again, we are at a juncture where we need to have the efficiency and overall performance also to be thought whenever we are communicating from one point to another, right? And this basically drives us to a level where we decide which entity is more suitable for a given reason. So there's no single encryption works for all. There are mix and match. There are depends on how much infrastructure you have at your disposal to do these encryption services, how much, even the communication area of communication or location of communication does play a part. Because if you go to entities or regions where internet communication is really slower, really is a challenge in terms of connecting and retrieving the packets and all, you need to have really reduced communication bandwidth. You need to have really efficient communication rather than secure communication. So there are kind of trade-offs whenever you use secure, because there are number of increase in packets, number of as I told you, even if the receiver server feels like the integrity is compromised, he might ask for another packet by itself, and that's how it happens. So the bandwidth increases whenever you talk about encryption, when you talk about more integrated communications and so on and so forth. So there are some medians normally used by industry, used by business, so that whenever you try to have serve a consumer base, that consumer base to be served at an efficient level where the consumer demands rather than what the business wants, right? So for that matters, we normally compromise on these levels, or we might use some different channel for different encryption or decryption methodologies, right? Now this table is not actually required, but I just want to share with you in terms of understanding how these trade-offs are made, in terms of what primitive ways to be choose, and how we can leverage the encryption to a level where it is viable for a given business, viable for a given communications, be it email, be it SMS, be it something like WhatsApp file transfer. We have to choose between one of these things. So let's try to understand encryption. Confidentiality, yes. Hash function, no. MAC, no, because we can have these things stolen or shared across. Digital signature, no. Digital signature, of course, is a public document. We just authorize yourself digitally, that's all, nothing else, right? And digital authorizations are normally being mandated by many non-repetition clause. Like whenever you file something like your W2, digital communication or digital signature is a need, right? Whenever you file a lawsuit in a legal system, digital signature is a need nowadays. Now, for why they made it so? Because they want to have that non-repetition clause perfectly secured or perfectly validated before initiating the other steps in this communication area. So that's how they made it. So all these things are used by different entity at different point. Okay. This is important because whenever we go on job, we need to understand how encryption is different from hash, how hash is different from MAC, and so on and so forth. These understanding makes us more enabled in terms of how effective my communication is in terms of a given requirement, not a generic nature. Okay, and as we've seen, these trainings are specifically on an umbrella level or a generic level, so I don't want to go into each and every of these details, because these are really great areas to learn, and great time and effort required to learn each of these. So I'll mostly stop myself on the encryption level. If you want to know about any particular level, do WhatsApp me, and we can have a session additional on that whenever we can, and we can go at depth at a particular particular type of services also. Okay, so that's how I'm sharing with you, because each of these areas have been targeted by a particular entity. In banking, in financial institution, encryption is the most foremost. We might use another channel for like something like OTP, like one-time password, or some key given to you, a magnetic key, which normally gets a number whenever you log in, and you need to key in those numbers, secure number. These are nothing but something like private keys shared across to you. Have any one of you used that token, which the organization gives you whenever you log in through VPN? You need to key in those number, whatever available on that token. Have anybody of you used those things? I believe IBM has those things previously. Even in enterprise rent-a-car, I use those, token ring authentication whenever they call it token ring, but it's actually a private key type of, methodology which these key generates, and you can include this private key and then have those decryption set up at your station level. Have anybody used that token or that small pager like things they give it to you to key in those number? Anybody is using that right now?
No.
Okay. Apeksha, have you seen that? Have IBM ever given you those things? Apeksha, are you there? I believe she left early. Okay, no problem. So, this is how we do it. So, if you want to have any, details or understanding of hash function, MAC or digital signature, do let me know. We can have a separate session on that. I try to limit myself for this encryption because mostly the financial institutions or even US military or, most of the employees in North America, they use encryption as their standard mechanism and a bit of hash function in a combination with encryptions, and we'll have a look at that in next few slides. It's almost 8 o'clock, and I believe Apeksha also step out, so let's stop for the day. I'll share the recordings link with you so you can go through them, and if you have any questions, do let me know, or we can discuss it tomorrow. We'll have our class tomorrow, believe me, same time, same place. Okay. So let me say bye right now. Thanks, Shivam. Thanks a lot. Let's meet again tomorrow, same time. And I'm sharing the recording link so that you can go through these things. And if you have any question, we can repeat these things, or we can basically try to understand in depth if you feel a need for anything. Okay? Sure.
Yep.
Thanks a lot for here today. Bye. Take care.
Bye.